Okay, this is a Algebra 2, 4-7, which is like page 136. We're looking at numbers 15 through 25. 15 through 25. And all of these are solving by factoring. Okay? Solving by factoring. So, let's take a look at number 15, which says 2a squared minus 5a plus 2 equals 0. All right, so the first thing we notice is that this is an equation set equal to 0, so that's the form we want it in order to factor. To solve, we want the equation set equal to 0, so that's good. Our equation is in descending order. It's got the a squared term, the a, and then the constant, so that's good. All right, so what we need to think about is when we have a trinomial like this, our goal is to factor it into two binomials that will be factors multiplied together that equals 0. So what we want to think about with our factoring into binomials is that the first term, let's do this. The first term times the first term, okay? When I say the first term times the first term, I'm talking about the first and second term of the binomial, right? There'll either be a plus sign or a minus sign here, right? Plus sign or a minus sign, right? So the first term times the first term equals this term right here, okay? So how do we get, what two things can we multiply together to get 2a squared? Well, let's just take it in parts, right? What can we multiply to get 2? Well, we can take a 2 and multiply it to a 1, right? And how can we get a squared? Well, that's going to be an a times an a. Okay? So we know that much. Now, this last term right here, the constant term, I'm going to include that sign. It's a positive 2. The way we get that last term is it's the last term of one binomial times the last term of the other binomials, right? And so it's a 2, okay? So our options are, it could be a 2 here and a 1 here, or it could be a 1 here and a 2 here, right? So that's our options, okay? Now we have to figure out which goes where. But before we do that, let's think about our signs. Because if we think about the signs, we may be able to figure out more easily whether the first binomial has a 2 or a 1. Okay, so let's think about the signs. Okay, so that sign right there, just a second, I've got the wrong pen going there. Okay, that sign right there means that the binomials have the same signs. Okay, how do I know that? Well, because remember that last term is the last term of the binomial times the last term of the binomial. And they're multiplied and they have to be positive. The only way you get a positive is if you multiply two positives or you multiply two negatives. Whenever I know that the binomials have the same sign, I know that the sign of the middle term of the trinomial is the sign that I need in the binomials. So there's a negative and a negative, okay? All right. So now I know that it's 2a minus something and 1a minus something. Those are my binomials. Now I have to think about this guy right here, this negative 5 in particular, okay? How do we get that negative 5? Let me go to a different color that's more different. There we go. How do I get the negative 5? Well, the way I get the negative 5 is it's these two, the last and the first term, multiplied together, plus these two. Okay? And so now we could just do a trial and error. Okay? If it's the 2 that goes in the first binomial, we'd have 2 times 1a, that would be 2a, plus 2a times 1, which would be 2a, and that's only going to get us to 4a. We need to get to 5a. Okay, I'm ignoring the signs right now. It would obviously be negative 2a plus negative 2a, which would be negative 4a. That's only going to get us to negative 4a. We need to get to negative 5a. So that's not going to work. So that solves it for us. Let's check it. Negative 1 times 1a would be negative 1a, right? Plus 2a times negative 2 would be negative 4a. Look at that. That's supposed to be a 4 there. Negative 1a plus negative 4a is negative 5a, and that's our middle term. So what did we just figure out? We figured out that it's 2a minus 1 is one factor, and 1a minus 2 is the other factor. So now we're solving 2a minus 1 equals 0, or 1a minus 2, I don't really need to write that 1 in front of the a, equals 0. So over here, this would be a equals 2, or, I don't really need to write the or again, 2a equals 1, a equals 1/2. So it's a equals 1/2 or a equals 2. Those are the two solutions. Okay, so this is the thing that then you have to be mindful of when you have a situation where the lead term of the trinomial is something other than 1. Okay, now in some cases you can actually factor. I mean, if this had been 2a squared minus 6a plus 2, you could factor out a 2 and then go from there, but that wasn't the case, right? So let's look at number 17, and let's just get this set up. Okay, so with number 17, it begins 6r squared plus 7r equals negative 2. So remember, the first rule is set the equation equal to 0. So this becomes 6r squared plus 7r plus 2 equals 0. Right? And that's an equals, not less than. My tablet every once in a while has an attitude. Okay, so now we're ready to factor. Now, the first thing I actually want to do when I see that my lead term is not a 1, I want to see if I can factor something out of the trinomial. Now in this case I can't, because I have an even 6, an odd 7, and an even 2. So I'm not going to be able to factor something out. So that means then I just need to go to my binomials, right? And so remember our pattern here of how we get the different terms in the trinomial from multiplying the two binomial factors, right? So when we think about the 6r squared, clearly there's an r times an r. But when we think about 6, and when we think about 6, there could be a 2 times a 3, and there could be a 6 times a 1, right? I mean, those are two options to get 6 for the 6r squared, okay? Now, the nice thing is I don't have to do a 2 in the first one and a 3 in the second one, and then a 3 in the first one and a 2 in the second one, I can take care of that with the other term. Okay, and I'll show you that here. Okay, so the last term here is a positive 2. All right, so let's think about our 2. It's either going to be 2 times 1 or 1 times 2. So notice with the second one, I alternate the possibilities, because if the 2 is here, it's going to be multiplied by either the 3 or the 1, depending on. If the 2 is here, it's going to be multiplied by the 2 or the 6, depending on which is chosen. Okay, so it matters where we locate that second terms. Okay. All right. Now let's look at the signals. The signals. I don't know what that means. Let's look at the signs. Right here we have a plus sign. What does that mean? It means that the binomials have the same sign. If they have the same sign, they have the sign of the middle term. So that means the plus and a plus. Okay, so that's good to know. Okay, so let's walk through our options. Okay, if it's a 2 and a 3 to make the 6r squared, okay, is it a 2 and a 1, right? 2 and 3, here, this right here is 6. This right here is 2. 6 plus 2 is 8. So that's out. So it can't be a 2r plus 2, 3r plus 1. Now if you need to, go ahead and write it out this way, right? You know, write your options out this way, okay? So you can see there's your 6r squared, there's your 2, okay? And then think about 2 times 3 is 6, 2 times 3r is 6r, 2r times 1 is 2r, 6r plus 2r is 8r, so that one doesn't work, right? Maybe we'll just do it this way, and it'll be easier to see. So 2r plus 1 and 3r plus 2. So notice now I switched the second terms. What do we have here? Well, 1 times 3r is 3r. 2r times 2 is 4r, so that's 7r. Perfect. All right, we're done. Once we've got a combination that matches that middle term, we know we're done. So our factor is 2r plus 1 times 3r plus 2 equals 0. Okay, and so you should be able to take it from there. That says 3r plus 2. I'll fix that. Okay, so you should be able to take it from there. All right. So notice how we did it. We thought of the possibilities, and then we started going through those possibilities one at a time. Fortunately, the second possibility worked. Okay. So I'll let you solve the rest of number 17, and we'll go on to number 19 and see about this one. So number 19 is this times this equals -3. Now the problem here is we might think, well, I can just go x minus 2 equals -3 or x plus 2 equals -3, but I can't do that, right? Because first of all, it doesn't really make sense. One of the factors doesn't have to be -3 in order for two factors to be multiplied together and equal -3. I mean, one of the factors could be, but that would require the other factor to be 1, right? But the factors could be something else. This is why it's important that things be set to 0. All right? So what do we do in this circumstance? Well, if I do this, x minus 2 times x plus 2 plus 3 equals 0. So now it's set to 0, right? But I've got a problem here because I don't just have two factors multiplied together that equal 0. I have two factors multiplied together that need to equal -3. And I don't know what, I mean, there's an infinite number of possibilities. The whole point is to have two factors multiplied together equal 0, because then you know at least one of them has to be 0. So what are we going to do? Well, in this case, In this case, what we're going to have to do is we're going to have to take these binomials and multiply them together and build the trinomial so that we can incorporate this plus 3 into the trinomial. In other words, we'll say x times x is x squared, right? We will say, what, negative 2 times x is negative 2x, and x times positive 2 is positive 2x, so those go away. And then negative 2 times 2 is negative 4. So we have x squared minus 4 plus 3, right? We have this plus 3 still, and that equals 0, which is to say we have x squared minus 1 equals 0, right? Because negative 4 plus 3. Well, now, you should know what to do at this point. This should mean something to you. This x squared minus 1 is what we call difference of squares, right? You remember that. That means we get two binomials that look exactly the same. The only thing that's different is the sign. One's positive and one's negative. Right? In this case, we get an x minus 1 and an x plus 1. And you can take it from there. All right. So in this case, where we had the two binomial factors to start with, or not the two, we had two binomial factors to start with, but we weren't set equal to 0. So what did we do? We expanded, right? We multiplied the two binomials together, built the trinomial, incorporated, in this case, this plus 3 into it, and we got a new trinomial, if you will, that we then could factor, set equal to 0, and now we can solve. Okay? So I will let you finish number 19. And over here, we will take care of number 21 if we need to. What do we have? Okay, with number 21, we have 15t squared plus 5t minus 10 equals 0. Now, something I said earlier should stand out to you if you remember it. It's kind of an odd way to tell it to you, but if you remember, previously I said when the lead term on the trinomial isn't a 1, before we start trying to factor into binomials, we should look to see if we can factor anything out of the trinomial. So let's look at the numbers. We have 15, we have 5, we have 10. Hopefully you recognize those are all multiples of 5. So we could factor a 5 out, which would leave us with 3t squared plus t minus 2 equals 0, right? So now we can ignore the 5 because the 5 is just the 5, right? So we can ignore that. Now we can factor the trinomial, right? Okay, and I would like to think that you'd be able to do this, right? The 3t squared, the only possibility is a 3t and a t. That's it. The 2, it's got to be a 2 and a 1, but the question is, does the 2 go here and the 1 there, or does the 1 go here and the 2 go here? That's the question, right? Let's look at the sign. The signs. This sign is negative. That tells me that the signs are opposite in the binomials. When the signs are opposite in the binomials, this sign tells me which one. This sign tells me the sign that goes to the larger number. But we have to be careful here, because remember, this number on t comes from the addition, right? We're going to multiply this guy times this guy and add it to this guy times this guy, right? So we have to be careful here. What we need when we do this, when we do these two multiplications and add, we need it to come to 1t, right? So let's think about our options. 3t plus 2 times t minus 1, right? Because we know that the signs have to be opposite, right? So here we have a positive 2t and a negative 3t, right? Positive 2t and a negative 3t. Well, I'm trying to write it there, but anyway. That's going to be negative t. Well, that's not good. That's not what we wanted, right? But it could be this way, right? 3t minus 2 and t plus 1. Now what do we get? Well, negative 2 times t is negative 2t. 3t times positive 1 is 3t. Negative 2t plus 3t is t. So there it is. Our factor is 3t minus 2, t plus 1, and that's equal to 0. And so you can solve from there. Okay, so what happened in this case? In this case, when we saw that there was not a 1 on the lead term of the trinomial, we checked to see if we could actually factor something out. In this case, we could. We could factor out a 5. Okay, and a reason for doing that is just it would make it simpler, right? Because once we factored that 5 out, we knew that it had to be a 3t times a t in our binomial. If we left it the 15t squared, right, it could be a 15t times a t. It could be a 5t times a 3t, right? Okay, so there's more options there than what we ended up having when we factored. Okay, so that was helpful to factor out the 5. And then once we factored out the 5, we could ignore it because what we care about are these two binomial factors and what it takes for one of them at least to be 0. Okay, let's go to number 23. 5 minus y squared plus y squared equals 13. Well, this seems to be a problem, right? Now, I would like to think that with any of these problems, you would think of something to do. Okay? For example, you see, one of the difficulties that students often face is they look at a problem and they want to know what's the last thing I do to solve this. And if they don't see right away what's the last thing I do to solve this, then they think they can't do anything. Right? That's a pretty typical pattern for a student. If I can't see the last step that solves the equation, then I assume that I'm not able to do anything in the equation, right? So sometimes you just need to take a step and just do something that you see that could be done, right? So when I look at this, I might think, okay, I have no idea how this is going to work out, right? But you could do something, right? For example, one of the things you could do is, okay, so I'm solving by factoring. I know that the equations have to be set equal to 0, so I can do this. I can set it equal to 0. Okay, I've done something, right? Okay, but now what? Well, I know that what I'm looking for is a trinomial that's in this pattern, right? ax squared plus bx plus c. Well, I don't have that. So what can I do to get it? Well, this quantity 5 minus y squared is really saying 5 minus y times 5 minus y. It is two binomials multiplied. So let's do it. Let's see what happens. 5 times 5 is 25. 5 times negative y is negative 5y. negative y times 5 is negative 5y. So that's going to be negative 10y. And then negative y times negative y would be positive y squared. Okay. There's a plus y squared, and there's a minus 13. All right, so how about I take all of this, I combine like terms, and I write it in an order that matches this standard form here. So I've got a plus y squared and a plus y squared. So that's 2y squared. That's what I want to start with. Here's a negative 10y. That's the next term I want. I have a negative 13, and I have a positive 25, right? So I have 25, I owe 13, I have 12. And that equals 0, okay? So what was my point here? Okay, well, the first thing, looking at the original problem, it's like, boy, I don't know how this is going to work out. But I do know this. I'm in a section of problems that I'm supposed to solve by factoring. So what can I do? Well, set the equation equal to 0. That's something I can do, because that's what I need it set equal to 0 in order to factor and solve. Okay. What I would like, if I can't just have the two binomials handed to me, what I would like is a trinomial in this standard form. Okay, so I didn't have it. Well, how can I get there? Well, when you look at this line right here, right? If you look at that line, you can say, well, I don't know what to do. Or you can look at that line and say, and ask the question, what is something I can do? Right? What is something I can do on that line? To rearrange it, to, whatever. The one thing that I can do is this multiplication that I did right here, right? That's the one thing that there is to do on that line. So do it. And that's what I did, right? And I got the 25 minus 10y plus y squared. So then I look at this line. What's something I can do? Well, there's a y squared and a y squared. I can put them together and get 2y squared. And write that first, because that's the way the first term of the trinomial should look. The negative 10y needs to be the second term, so I'll write that second. Negative 13 and 25 are like terms. I can combine them. And guess what? I've got now a trinomial that's in this standard form. Okay? So now what's the next thing I can do? Well, I notice that the lead term is not 1. So can I factor something out? Well, there's a 2, a 10, and a 12. They're all even, so yeah, I can factor out the 2. And this can become y squared minus 5y plus 6 equals 0. Look at the progress I made. And it all started with me, I don't know how this is going to work out. But there's one thing I know. When I solve by factoring, the equation has to be set equal to 0. So let's set it equal to 0. Okay. I don't see how that helped me. But I look at that line and I think, what's something I can do? Oh, I could take 5 minus y and multiply it to 5 minus y, right? I could square 5 minus y. There it is. And I got this. Oh, I can put together like terms. And now I'm down here where I can factor, excuse me, and solve. And so I'm going to leave it at this point for you to do. Factor the trinomial into the two binomials and get your answer. The 2, we can ignore it because 2 doesn't equal 0. Right? 2 doesn't equal 0. But one of these binomials at least does equal 0. All right. I walked through that a few times because I wanted to demonstrate to you that even though you look at a problem and you might think, I don't know how to solve this, stop trying to think of the last step you need to take to solve it and just think about what's in front of me and what's one thing I can do. Now, it's very possible that you'll see something to do and it leads you in the wrong direction. That's entirely possible. But better to do something and find out, well, that was the wrong way to go, than to simply say, well, since I don't know the last step I need to take to solve it, apparently I can't do any of it. Because that's simply not true. You can think of something to do. Now, you might think to do this first step and get to 0 and just be stuck there, and you think, I don't see anything else I can do. You might legitimately think that. Okay, but at least you did something, right? At least you demonstrate that I know something about how to solve these problems. At least you know that when you have problems where you are to solve by factoring, the equation has to be set equal to 0. Okay? All right. A little motivational speech. Now, my guess is if you look at number 25 now, with all the wisdom I've given you, you could think of how to solve this equation. Okay? So I look at it, right? What's one thing I don't know the last step to solve it. Oh no, panic. What's one thing I can do? What's one thing I know about solving equations by factoring? The equation has to be set equal to 0. So let's just do that. Okay? Right? So with any of these problems, one of the first things that you could think about is the equation set equal to 0? If it's not, make it be equal to 0. That's always a way to start in solving by factoring. Okay? So to do that, I'm going to end up with this, right? Okay. And you might think, oh, that just looks too complicated. Well, okay. But remember, if the lead, once you get your equation set equal to 0 and you've got the trinomial, right? If you don't have a trinomial in standard form, then figure out what you can do to get a trinomial in standard form. But here we have a trinomial in standard form. And hopefully you understand why I'm calling it a trinomial. There's 3 terms. There's 2n squared is a term, 18n is a term, 720 is a term. Okay? Now we've got a trinomial and it's set equal to 0. Look at the first term. Does it have a 1? No, it doesn't. It has a 2. We call that the coefficient on the term, by the way. Its coefficient is 2. We can say the lead coefficient is 2. We call it the lead coefficient because it's at the lead of the trinomial. It's at the beginning of the trinomial. Right? So it's a 2. I'd prefer it to be a 1. Can I factor out a 2 from every term? Well, every term has an even coefficient, a 2, an 18, a 720. Yeah, I can factor out a 2. What do I get? N squared minus 9n minus 360 equals 0. Now I can ignore the 2 because 2 definitely doesn't equal 0. But if I factor that trinomial into 2 binomials, one of them at least has to equal 0. And I'm pretty sure that you can take it from there and solve it. Okay? All right. So there you go. Help on numbers 15 through 25, 4-7, Algebra 2. I hope it helped you. I hope you understand these problems a little bit better. I hope you realize that you can, even if you don't know how to solve it from the start, you can think of something to do. And once you find one thing you can do, it usually leads to other things that you figure out to do on the way. All right.